For this example, we're going to be kind of going in reverse of what we have for the previous ones. We're still going to be thinking about our formula for a vector, which is magnitude times the cosine of the angle, sine of the angle. We're going to be thinking about that formula, but what we're going to be asked to do is take these vectors that we have set up and to go the opposite direction, actually find the magnitude and the direction angle of the vector. Now, for part A, if you have just this simple vector here, the magnitude is really pretty straightforward. If we want to take the magnitude of that one, we just do our little square root formula, which will be -1 squared plus 2 squared, giving us the square root of 5. So that's the magnitude in this first part. For the second part, if we're going to find out the direction angle, we actually have to use some inverse trigonometry. So it goes back a little bit to chapter 4. I know everybody loved this one, but we need to think about what that angle is going to be. So to do this, I'm just going to start by drawing a little picture. Now the way we have this is -1, 2. That's going to put it in the second quadrant, and that's going to make this -1 for the x and +2 for the y. Now we found the magnitude already. That actually happens to be the hypotenuse as we're making this triangle and using some inverse trig. What we need to do is we need to find what is the angle that produces this. So our alpha here, that's our question, it's our missing angle. We find missing angles by doing the inverse trig. Now in this particular case, since we're in quadrant 2, I suggest using cosine inverse, because as you know, the range for cosine inverse includes 1 and 2. So this one won't require any adjustments if we use cosine inverse. So cosine inverse of, well, we want adjacent over hypotenuse, and so we're going to do -1 over square root of 5. Now that is, we don't need to simplify that or anything from this one. We can just simply go to the calculator and use this. So making sure that you have it in degree mode, as I do on my calculator, I'm going to enter that in and do cosine inverse of -1 divided by the square root of 5. And I get, for an angle here, it looks like in degrees I get about 116.6 degrees, which is what we're kind of expecting, because it makes sense that that angle is in quadrant 2. So that's part A. Part B is a little bit different story, but some of the same stuff. One thing I would like to just mention here is that the i's and j's, if you don't like working with those, you can certainly put that into pointing brackets, put it into component form instead. I kind of like to do that. So I'm going to change this to -3, -5. Those two mean the exact same thing. And like before, I can find the magnitude by just doing our little formula. So that's going to be the square root of -3 squared plus -5 squared. And that will simplify to, so we've got 9 and 25, so that'll be the square root of 34. So there's our magnitude. The next thing that we're going to do is find the direction angle. Looks like I'm going to need a little bit of space down here, so we'll hope that this one doesn't get quite as crazy. But we're going to find the direction angle, and like before, I think it's a good idea to draw a picture of this. And this picture, we've got -3, -5, so that's actually going to put it in the third quadrant. And some of you might already be thinking that there's a problem with that. And we'll address that. So we have -3 and -5, and if we want to put our hypotenuse in there, we found the magnitude, which is the same as the hypotenuse, but this is in quadrant 3. And if you remember, none of our inverse trig functions worked in quadrant 3. So we have to somehow adjust for that. The one that I think is good to use when you're in quadrant 3, when none of them work, is actually to try tangent inverse. Now, if we do tangent inverse, in this case of opposite over adjacent, that'll be -5 over -3. Now, since we have two negatives, that goes into a positive. So essentially what this does is that means the same thing as 5 over 3, which if we're talking positive, that would put us in the first quadrant. So we're going to look for this basically like it's in the first quadrant and it's +3, +5. Now once we get this angle, once we get our alpha here, we are going to have to do something with that that's in the first quadrant. So in order to translate it to the third quadrant, we're just going to have to add 180 degrees, because you can see here, this is going to be 180 degrees from this original. So tangent inverse, of 5 over 3, go back to the calculator here, make sure it is in, again, the degree mode, gives us, whoops, I put tangent as tangent inverse of 5 over 3, and so that's about 59 degrees. Really close to that, so we'll just call it 59 exactly. Then if I want my actual direction angle, I take that 59 now. My angle for this one is just going to be 180 plus 59, which will give me a total of 239 degrees, which makes sense because that is going to put us in the third quadrant. So we've got 239, we've got square root of 34, that's our magnitude and direction angle for number 2. Now the last one, a little bit of a break. This one won't be nearly as bad. This one here, you'll notice that we've got the 2 out in front and we've got 60s. So really the 2 is just our magnitude, and then the 60 is our angle. So there's really nothing to this one because of the way it's set up. It's set up so much like our formula up here.